right, we're going to start this packet with addition and subtraction with scientific notation. The biggest thing to remember, so make a note of this, that's a really crummy star, is powers must be the same. All right, so we might have to do a little number wiggling for some of these problems. Some of them we won't. We'll just have to look at them, but your powers must be the same. And when I go to change these powers and do the breaking up of the numbers, I need you to understand that the number that I choose to break up doesn't have to be the number broken up. You can do either number, okay? Sometimes you'll get your answer in perfect scientific notation. Sometimes you'll have to fix the scientific notation. There's almost no way of knowing. You just get lucky. All right, so let's look at number 1. 3.1 times 10 to the third plus 4.3 times 10 to the third. I see that my powers are 3 and 3. They match. I don't have to change anything. So I can just do 3.1 plus 4.3. Either you can do it in your head, you can do it off the side, or you can put that into a calculator. Why does my calculator look like that? Okay, sorry. And you get 7.4. So 7.4, and we're going to keep the power, times 10 to the third power. It's important that you check your answer to make sure it's in scientific notation. A times 10 to the n, and A's absolute value is at least 1 but less than 10. So number 1 is good. Let's look at 2. I have a 1 and a 2. Those don't match. Okay? So what I'm going to do is I'm choosing to change the 1. Okay? So I'm going to keep my first factor. I'm going to split the exponent into 2 powers. And I'm going to just rewrite that second one. Now, I need my powers to match. So the second power that I make is going to be 2. Sorry, my TV just went stupid. Now, what do I do to get 2 that equals 1? Okay, so think about that for a second. If I do -1 plus 2, I get 1. Okay? Now, we have 2 powers in our parentheses, which it's okay because we needed it, but we're not going to keep it that way. So whichever power doesn't match that we made, we're going to use to make a standard form. So 3 times 10 to the -1 is 0.3. And then I'm going to rewrite times 10 squared plus 6.4 times 10 squared. Now my powers are the same. 6.4 and 0.3 give me 6.7. And I'm going to keep the power. All right, so let's recap what we did. Well, let's check the scientific notation. I'm sorry. It's between 1 and 10. It looks good. I'm done. All right, so my powers didn't match. I chose to change the 1. I know I needed to have a 2. And I know that 2 plus -1 gives me 1. But I can't keep 2 powers in my parentheses. So I used the extra power that didn't match, and I combined it with the first factor. Okay? Then, since the powers matched, I added my first factors, and I got my answer. Let's try another one. 2.4 times 10 to the 4th plus 5.7 times 10 to the third. It does not matter which one you change. Okay? Let's go ahead and change the 3 to a 4 this time. Just because we can. So 2.4 times 10 to the fourth plus 5.57 times, I have two powers. One of them is going to be 4. I like to put the matching one second for the next step that we're going to do. All right. What can I do to 4 that's going to give me 3? I can put a -1. It's not always going to be a -1. It just happens to be a -1 again. So now I have two powers right here. I have to get rid of one of them. So 2.4 times 10 to the fourth power plus, now I'm going to do 5.57 times 10 to the -1. So that decimal is going to move one time and make it smaller. And I'm left with 0.557 times 10 to the fourth. Now I can just add those numbers up. 2.4 plus 0.0557. Pause this if you need to do the calculations. Is 2.957 times 10 to the fourth. That one just so happened to be that we didn't have to change the scientific notation. It just worked. We got lucky for the last two. Okay? And I'll try number 4 with you. Let's see which one we're going to change. Let's change the -3 and see what happens. So 5 times 10 to the -2, we're going to keep, plus 1.6 times, we're going to have two powers. My second one's going to be a -2 because I have to make it match the first set. Now, what with -2, when I add it, I get -3. Spoiler alert, it's another -1. I'm sorry, I'm not doing this on purpose. -1 plus -2 gives us -3. Okay, so go ahead and combine these two. (1.6 times 10 to the -1 is 0.16 times 10 to the -2. Add them together. We get 5.16 times 10 to the -2. Let me show you what would have happened if I would have changed the other number, because I want y'all to see the difference. So we have 5 times 10 to the -2 plus 1.6 times 10 to the -3. I'm going to make both of them -3. So 5 times 10 times 10. One of them's going to be -3. I know that -3 plus 1 gives me a -2. So that's going to be the other power. And we're going to copy down the rest. Now, combine your first factor with the non-matching power. 5 times 10 to the first is 50. Keep the matching power. Now 50 plus 1.6 is 51.6, and we keep the power. But that's not good scientific notation because the absolute value of this is greater than 10. So I'm going to move my decimal one time. I'm going to make this number smaller. I'm going to turn it into 5.16. Because I made this number smaller, I have to make this number bigger by however many times I moved, which is 1. So times 10 to the -2. If you notice, we got the same answer. It took an extra step with the scientific notation, but we got the same answer. Okay, so you can do that either way. Let's look at a subtraction problem. Let's jump to number 9. All right, we can change the 5 or the 2. Let's change the 5 to a 2. So 1.39 times 10 times 10 I need to make this a 2 to make it match. Now, what plus 2 is going to give me my original 5? That's easy. That's going to be 3. Now, combine your first factor and your first power. 1, 2, we're going to have 1,390 times 10 squared. Sorry, I need to fire my cameraman. Just joking, that's me. Minus 4 times 10 squared. Now my powers are the same. I can subtract. So I'm gonna go to my calculator. My calculator looks different from yours, but it's gonna work the same. I'm gonna do 1390 minus 4. I get 1386. That's not good scientific notation. So 1, 2, 3 times I'm gonna move. I made smaller, sorry. So I'm gonna add 3 right here. So I get 1.386 times 10 to the 5th. It's the same thing as adding, except you're gonna subtract your numbers. Okay? Go ahead and pause the video. Finish your addition through number 14, and then we're gonna go into multiplication and division. Go ahead and pause. All right, multiplication and division. This one, in my opinion, is so much easier. So you're either gonna multiply or you're gonna divide, and then you're gonna add or subtract. So this is talking about the first factor, and this is talking about the exponents. If you want to make yourself that note, that's what you do. Okay? You definitely need a calculator for this part, because I can't do these numbers in my head. I don't know about you. All right, so first factor times first factor. So 1.08 times 9.3, I get 10.044. And then I'm gonna add my exponents. -3 plus a -3 is -6. That's not good scientific. So I'm gonna change it. Move this over 1 time. It got smaller, so this gets bigger by 1. So I have 1.0044 times 10 to the -5th. It's that simple, that quick. Let's do another one. I'm going to multiply the first factor. So I have 2 and I have 8.1. Nope. Times 8.1 should give me 16.2. Now add -4 plus -1 gives me -5. But that's not good scientific notation. So let's move. I'm gonna move it to right there. So I have 1.62. Because I got smaller and moved 1 time, this gets bigger by 1. So times 10 to the -4th. Pretty simple. Let's look at a division problem. We're just going to do the opposite of what we did. Instead of multiplying, we're going to divide. Instead of adding the exponents, we're going to subtract them. All right, so divide these two numbers. 7.1 divided by 8.2. We're going to round that. Let's do 0.87. Yeah, my answer key doesn't round it, but we're going to round it because that's a big number. So 0.87 times 10, and then do 6 minus 1. That gives me 5. That's not good scientific. So move this over one time to make 8.7. This number got bigger, so this number needs to get smaller by 1. And we get 8.7 times 10 to the 4th. Okay, let me make myself a note on my answer key that I told y'all that. That way when y'all go to check it, y'all are not like, oh my God, Miss Blanchard, you got different numbers. No, we rounded. It's okay. All right, let's do number 8. We're going to do the first factors. 5.4 divided by 3.4. Again, really big number. Let's round that to 1.6. Now be careful with this. -1 minus 1. 1 minus 1. Keep, flip, change, or whatever. So plus negative. That gives me a -2. That's good scientific notation. I don't have to change anything. It's good just like that. All right, let me make a note. 1.6, we rounded. All right. Look at 13. It's a little different, but it's nothing you haven't seen before. Remember, there's an invisible 1 right here. So the 4 gets distributed or multiplied to both exponents. So I'm going to have 8.9 to the 4th power times 10. 5 times 4 is 20. We can put that in our calculator. Sorry, I just had a blonde moment. So 8.9. Your calculator is different from mine. My exponent button's over here. Yours should be right here. So to the 3rd power. Yours is going to give you the little up arrow on your screen. Mine just formatted it different. It's just because it's a different calculator. It's going to give us the same answer. Maybe. Oh, to the 4th power, not the 3rd. See, that's why we pay attention. 8.9 exponent key 4. That looks better. So I have 6274. We can just keep it like that. You can round it. Times 10 to the 20th. That's not good scientific. So 1, 2, 3 times I moved to get smaller. So 3 times I get bigger. 6.274 times 10 to the 23rd. Remember, if you don't see an exponent, the exponent is 1. If you have an exponent outside parentheses, it goes to all the exponents inside and gets multiplied. Okay? Let's see what your next page is, if there's anything different. Nope. Y'all can handle that. Good luck. Come see me if you have problems or to check your work. Good night.